Today, we're learning about how do we solve trigonometric equations. Now, the main idea here is that in order to solve a trigonometric equation, we're looking for an angle that will make the statement a true statement. Previously, when you were solving for something, it was always a variable. Now, when we're solving for trig functions, we're actually not solving for a variable, but we're actually solving for an angle. So keep that in mind. The main idea, we will solve for the angle when we're solving trigonometric functions. So let's see some examples here. Now, we need to pay attention as to how they want our answers here. So they're asking us to solve each equation, and our angles, or our answers, they need to be between 0 and 360 degrees. So keep that in mind. So how do we solve equations which involve trigonometric expressions? Okay, so the first thing that you want to do is you want to isolate the trigonometric expression here. We want to isolate sine of x. Because we're solving for this x, which is the angle, we first need to isolate the whole trigonometric expression. So how do we do that? Notice that the negative 1 does not have a sign, so we're going to move that to the right side by adding 1. So now we have 2 sine of x equals to positive 1. Again, we're solving for sine. This 2 is multiplying, so if you want to get rid of it, you need to do the opposite, which is division. This way the 2's will cancel out, and now we have that sine of x is equal to 1/2. Excellent. So we solve for the actual expression here. But this is not the solution. We actually want the x to be isolated. We want the x to be alone because we want the angle. So how do we obtain the angle? Well, you need to eliminate the sign. And this is going to be a new process. If you want to eliminate a trigonometric function or expression, you need to multiply by its inverse, where the inverse is being represented by exponent -1. So we're going to multiply the inverse to both sides. Because when you multiply an expression by its inverse, they will always cancel out. So now we have that x is equal to the inverse of 1/2. So this is your solution. Now we're going to use our calculator to find the exact representation for that expression. The inverse of sine of 1/2. When you're using your calculator, make sure it's in degree mode. So let's check that. Mode, move it to degree. So we got degree. Now that it's in degree mode, let's quit. Let's actually put that inverse of sine is located in yellow on top of the sine. So we're going to press second, sine. And now we're going to put, what is it that we want to find the inverse of? 1/2. So our answer is nothing more than x is equal to 30 degrees. Now, there's times where you need to check for another answer here. When we use the inverse of sine, there's times where you might have two solutions. So we need to check. This is our first solution. There's times where you have a second solution. So how do we check if there is a second solution? Well, if we took the inverse of sine to check for the second solution, we are going to get 180 degrees minus the answer that we arrived first, which is 30. 180 minus 30, that's 150 degrees. So my guess is that my second solution is 150 degrees. How do we check if it's true? Well, let's see what happens when you take the sine of 30. So we take the sine of 30, we obtain 0.5. Let's take the sine of 150, which is my second solution, the sine of 150 degrees. Notice that when we take the sine of 30 and when we take the sine of 150, we get 0.5, which is 1/2. So that says that both of them are my solutions. So your final answer okay, your final answer is when x is equal to 30 degrees and x is equals to 150 degrees. Remember that when we take the sign of inverse, we need to check for a second solution. And how we check for a second solution? It's by doing this. 180 minus the previous answer that you obtained here. So make sure you check for both solutions. This is only true if you multiply it by sine of inverse. 180 minus the answer will give you a second guess to see if your second answer is correct. So now let's do another example here. We'll talk about cosine in a second. Let's see. Now in example 2, same idea here. We want to solve, so we're solving for this angle. The first thing I want to do is isolate the sign. So notice that I need to subtract that 3 in order to leave the sign alone. So minus 3 to both sides. So now we have that sine of x, or sine of theta, 2 minus 3, so that's equals to negative 1. Again, you want to solve for the theta, you want to solve for the angle, you need to eliminate that sign, so we're going to multiply the inverse to both sides. Now that you multiply by the inverse of both sides, you need to keep in mind that you need to check for the second solution here. So we know that theta is equal to sine of negative 1 minus 1. So let's see what that is. Let's check what the sine of negative 1 is. So second sine negative 1. So now we obtain that our answer is negative 90. So theta is equals to negative 90. We got to check for the second solution. Okay. Now, if you remember, if we took the inverse of sine, how do we get our second solution? Our second solution is going to be 180 minus the first answer that we obtained here. So for second solution, we're going to have 180 minus the second answer that we obtained here. So now what does that give me? That gives me 270. Well, let's check if both of them are true. Let's take the sine of negative 90. So we're going to take sine of negative 90, which is negative 1, which is okay. Now we're going to take the sine of 270, which is negative 1. So see that both of them notice that both of them give me negative 1, which is okay. But now, are both of them going to be my solutions? No, they're not, because we got to remember what was the restriction here. We want only the angles which are between 0 and 360 degrees. Negative 90 is not between 0 and 360, so that says that my only answer here is when theta is equal to 270 degrees. So we don't take this answer in consideration because negative 90 is not between 0 and 360. 270, it is between 0 and 360, so that's the only answer that we take in consideration. So now what happens if we're solving for cosine now? Because we have two examples here. We talk about sine, but what happens when we talk about cosine here? The idea is still going to be the same. We want to solve for the trig function, for the trig expressions here. So let's solve for cosine. Notice that this 2 has been multiplied, so we're going to divide it by 2. So now we have that cosine of theta equals 1/2. Now we're not going to multiply by the sine, negative sine, or the sine inverse, but we're going to multiply by the cosine inverse. Because that way they will cancel out. And now we have that theta is equal to cosine inverse of 1/2. So let's check what that is. Let's check what's the numerical value for that. So now we're going to have negative cosine inverse is in yellow on top of cosine. So negative cosine inverse of 1/2. So that's going to give me 60 degrees. So we know that theta is equal to 60 degrees. But now, when we multiply by the cosine inverse, we still got to check our second solution. But now we're going to find our second solution a little bit different. The second solution is found this way. 360 minus the answer. So now we're going to get, for the second solution here, we're going to get 360 minus our first solution, which is 60 degrees. So that's going to give me 300. So let's check if 300 gets me the same answer as 60 degrees. So let's check. What's the cosine of 60 degrees? The cosine for my first answer, it's 0.5. So now let's check if the cosine of 300 degrees also gives me 0.5. 0.5 as well. So that is true. Oops, we said it was 300. So here are your two answers, 60 and 300, because both of them give you the same result. You don't have to check all the time. This is always going to be true. We're just checking this video so you can be exposed to the idea here. But you need to come up with a final statement. The answer is when theta is equals to 60 and theta equals to 300. Again, you don't have to check every single problem, but because it's the first time that you're exposed to it, we just want to make sure it's true. But you're always going to find the second solution this way. If we multiply by cosine inverse, you got to check for the second solution, 360 minus the answer. And if you multiply by the sine inverse, it's 180 minus the answer. So let's check. For the example here, let's solve for cosine. So how do we do that? We have here cosine. Let's eliminate that one. So -1 to both sides. So now we have 2 cosine of x. Okay. 2 cosine of x equals -1. Want to solve for cosine, divided by 2. So now we have that cosine of x equals -1/2. How do we do that? Want to solve for theta, or x in this case, so you got to multiply by the inverse. Multiply the inverse on both sides, they will cancel out. And now we have that x is equal to the inverse of cosine of -1/2. So let's check. What's the value of that? Negative inverse of -1/2. That gives me 120. So x is equal to 120 degrees. Let's check for the second answer. We got to check the second answer because we multiply by cosine inverse. And because it's cosine, it's going to be 360 minus my first answer, which is 120. So what does that give me? 360 minus 120. That gives me 240. Notice that both answers are between 0 and 360 degrees. So my conclusion here is when x is equal to 120 degrees, and when x is equal to 240 degrees. So we're going to stop the video here. This is just an introduction. On the next video, you will see examples which are a little more difficult because it involves more than one trigonometric expression.